All right, so these next 2 weeks are going to be basically a study in contradictions, essentially. On the one hand, I feel like I've assigned the most, sure, I'll go with the word difficult homework for our class. It's worth so unlike the other assignments, it's worth 150 points as opposed to 100 points. However, it's not due until not this Friday, but next Friday, and I'm not going to be giving you any more assignments in between. So you've got 2 weeks to work on this one. Okay. Secondly, I will try to do my best to go through and do it. There isn't going to be too much in the way of in-class exercises, other than try to show you how to properly use hash tables. I posted a lot of videos. I tried to, and on the announcement, I tried to make clear where the ones I think are important. Really, the ones I think are important right now are the ones that you need to watch to understand how to use a hash table, sets and maps. But building a hash table from scratch, that's something that's, that can wait until like next week, as well as the analysis video that I still have to put up on that. How do we know that these hash tables run in constant time? Right now, we're focusing on the using rather than the building, right? And the strategies we use are actually fairly straightforward for handling the how do we build hash tables. So so that's where we're at with hash tables. And I wanted to just take a moment to go over the assignment that I wrote. Although, to be fair, I didn't come up with this. I just simply did what you do for every grade assignment, which is that I found somebody else's really awesome assignment and blatantly stole it. So this is my version of Hangman. It is the Cheater's Hangman. Okay, it is. So there are 4 pages, but a lot of it is just simply an explanation of the homework, which I'd like to go over right now. This one, because it's also a bit more difficult, you're allowed to, normally with the previous assignments, you've been having to demo it by yourself. With this one, you can demo it with a single other person, right? So you can work with someone and you can demo it with someone, as opposed to demoing it with yourself, just by yourself, right? So you can both work on this and explain this one. You're going to be using a couple different data structures here, primarily array lists or whatever list you want, and maps. So this one's all about Hangman. So who here does not know the game Hangman? Right? Because, believe it or not, I have to explain it every single semester to one of my TAs because they come from China, and that is not a children's game they play in China because China does not have 26 characters, thus making Hangman an exceptionally difficult game for them. But if you don't know what it is, you probably encountered it in 1068 or before. It's a very classic, 1068, intro to programming problem. Program a game of Hangman, which is basically we just simply have the user guess letters and we reveal them, and if they make too many guesses which are wrong before they can reveal the entirety of the letter, they lose, right? That's Hangman. Okay, here we're going to ramp that up to 11, and we are going to make a game of Hangman, which ideally the person who's trying to play it is not going to win it. Because playing a game like Hangman relies on trust. So let me give you an example. Suppose we're playing a game of Hangman. There's 4 letters right? The 4-letter, right? And we've revealed the following letters so far. G, O, A. We've guessed. Now, based on your knowledge of the English language, and right, we've made a number of bad guesses, and we have only one guess left, right? So we've got G-O-A. There's only one letter left. You have one guess left, right? And based on your knowledge of the English language, what are we can think it might be goal, or it might be goat, right? We know it can't be goad because we already guessed D. Any other letter we've already guessed, right? We have one guess left, and we know just based off the English language, it's either going to be L here or T here to complete, right? Is everybody following what I'm saying here? One guess left. So now in a normal game of Hangman, you're going to guess something. Like, suppose I'm thinking of goal, right? Suppose the secret word is goal. In a normal game of Hangman, you've got a 50-50 shot. You guess L, you're right, and you win. You guess T, you're wrong, you miss your last guess, and you lose. Okay? However, in our version of Hangman, we're going to cheat. We're going to cheat. If you guess L, I am going to say, oh, I'm so sorry, the word I was thinking of was goat. And if you guess T, I'm going to say, oh, I'm so sorry, your goal was to think of the word goal. Sorry, you lose. So that is Cheater's Hangman in a nutshell. We are going to cheat. All right, so everybody kind of gets the premise? Now, we have to cheat. Now, here's the rules for cheating. You can't get caught cheating, ever, right? We're not allowed, suppose that we have the player has two guesses left, right? They guess goal, we go, oh, so sorry, you're wrong. They guess T, we can't say, oh, I'm so sorry, the word we were thinking of was goal. They'll go, wait, no, I guessed L, right? That makes sense to everybody? Right? It could be, right? If we guess goal, you can't get, we'll cross it off and we'll go like, okay, so the only thing left that makes sense is to put T here. We put T here. And we don't say, no, we were thinking of goal. We say, okay, I guess you win. Okay? So you can't get caught. And the only reason you're going to get, and getting caught in this case means basically like, coming up with contradictory words. So we're just going to prevent that from happening, right? Once they've guessed a letter, we're not going to use it in our hidden word anymore, right? So, but the idea here is kind of like if the idea here for the way this works is that suppose that we have the ability to stop time and we've got a dictionary, and for some reason we're deciding to use this ability to pwn everybody at Hangman, right? Because that's a really good use of our time, right? All right, but suppose we had that, right? If we had a dictionary and the ability to stop time, we could basically, whenever somebody guessed a letter, we could stop time, right? We could look through something, we can look through and basically divide it up into a bunch of categories and say, okay, if we let the user select these letters, then awesome. Then he's more likely to lose, right? If we say no, or if we reveal some letters, maybe they're more likely to lose now. And then we unpause time, and then we basically go for it. We don't actually have like a set secret word. We like keep a bank of words that we could possibly use, and then as the user guesses them, we eliminate them. And let's demonstrate that with over here on this example over here. Suppose these are the only. So rather than sticking with a single word, we can make a list of all four-letter words. There's a lot of inappropriate four-letter words, so we're just going to assume that these are the only four-letter words that exist, right?
I can think of a few.
Yes, I'm sure you could. But for our example, this is keeping just our four-letter words to this example is this. So suppose we're playing a game of Hangman which has only 4 letters, right? Right? So we gather all these into a list, and we lie to the player, and we tell them we've chosen a hidden word. We haven't. We've got a list of possible words that we can use. All right? So then what's going to happen is the player will start. They'll start by guessing most likely E, because that's the most common letter in the English alphabet, right? So now, especially it's also like the most common in our example here. There's lots of E's in this like condensed dictionary of 4-letter we have. So let's take a look at all the possible words we have. We have this team, look good, eggs, echo, edge. So what we can do is that we can categorize these into what we'll call word families. And if you've listened to my lectures on maps, then you'll know that the data structure you want to use for categorization is a map. So we can categorize these into word families, right? Based on what would be revealed, depending on basically words that would look the same based on what was revealed, right? This looking good all look the same if we don't reveal anything, right? Make sense to everybody? E blank blank blank, they'd see E blank 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 if the word was eggs or echo. They would see blank E blank blank if the word was tea, right? Because it's not just the number of E's, but it's also the position of E's, right? And then we would see E blank blank E if the hidden word was edge. Now, obviously, so here we have to make a choice. I don't want that to reveal blank E blank blank or E blank blank E, because that would kind of lock me into a choice with one word. Everybody see that, how that locks me into a single word choice, and now I'm just playing a regular game of hangman, and that's boring. Okay. On the other hand, if I reveal an E, I've got two words, right? I could be doing eggs or echo, or if I don't reveal anything and tell them they're wrong, they lose a guess, and I still got three words to use, right? So there's many different strategies you can use. So the general idea behind this, the general algorithm, is that they make a guess. You split all your possible words that you have, your word list, into word categories, right? So you have these different categories based on what would be revealed. And then you choose one of those categories as the one you're going to use for the future guesses, right? We cut down our word choices based on what would be revealed. There's a lot of different strategies. The one I'm going to use, which is the easiest one, and I'm going to use the word category that has the most words in it, thus giving me the most to dodge. There's other valid ways you might want to use that might work better. Like you might want to use the word category that has the more obscure words. Like, oh no, I'm definitely going to go with the category if the category has a word that doesn't have any vowels in it, because that's going to completely mess with people's minds, right? So, they're not that uncommon, like sky, right? So we can go with that. We can go with that kind of thing maybe. But for simplicity's sake, I'm just going to choose the one that has the most words in it. So I'm going to go with blank 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 blank. I'm not going to reveal anything. I'm going to say no, E isn't in any of the word. Sorry, the word, right? The word I'm thinking of. What? I'm not thinking of multiple words. So I'm going to say E's not in the word. So you lose a guess, and then we basically are left with this looking good as our new word list. Okay? Make sense to everybody? We've kind of reduced down. So next, they try guessing O, and they'll have blank OOD, and that will have look and good in one category. So I can either reveal two O's and have look and good, or I can have four blanks and this. And my algorithm would then say, we choose the one with the bigger with the bigger category. We reveal two O's, and we don't mark off any wrong guesses for the user because they guess correctly that there are O's in the word, right? And so the game will end when the user guesses all the letters for the word, right? The game ends when they fully reveal the word, or they or they get the maximum number of wrong guesses, in which case they lose. And they're most likely going to lose, right? Unless you give them an inordinate amount of guesses, like 10 to 15, they're probably going to lose. Give them a normal amount of guesses, like 5, they're definitely going to lose. Okay? So so I've given you basically kind of the algorithm for the way this is going to work. The first thing you have to do is read in the dictionary file, which I'm just simply using the words.txt file that we already have instead of dictionary.txt, the word file that we already have. You want to store it in your program, so you're going to store it in your program this time, rather than you're going to just store these into a list. You're not going to make any special data structure with these. Ask your user to choose what size they want to play with, right? They want to play a 4-letter, 3-letter, a 5-letter, 7-letter, 13-letter word, right? Of course, if they choose an invalid option, like if there's no words of that length, then tell them so, okay? Ask them to choose how many wrong guesses they have before they lose, right? So they can modify the difficulty on their own. And so we'll create our initial list of hidden words by looking at our dictionary of words, right? We're going to go through our word list, and we're just going to simply grab all the ones that have that are of the appropriate length. Or you can simply create it, or you could create a map which says, here's a list of all the one-letter words, here's a list of all the two-letter words, three-letter words, four-letter words, and that's actually going to be a lot quicker for this. This goes on blazingly fast behind the scenes. There's, you know, if you do it right, the user won't notice that there's some hoodwinking going on here. And then we play hangman using our cheating algorithm once we've got our initial list of hidden words. We print out revealed letters, the wrong guesses, and the remaining number of wrong guesses. Get the user's new guess, be nice, and ask them to re-enter their letter. Figure out your hidden words based on their word families, based on the input. Choose a word family that based on some strategy. Again, I use the strategy of let's just choose the biggest word family. You can use that one too, but you know, feel free to experiment and make that the new hidden word list. If it reveals letters, reveal the letters. Otherwise, they lose a wrong guess, and then just keep going until you know, hangman ends. They either run out of guesses or they somehow win. And then ask if they want to play again. Okay. So the main thing here is that I'm not giving you any real code to go with. So first and foremost, as long as it works, there's no right or wrong way to do this one. It either works and you can hoodwink the player, or it doesn't work. But figuring out what data structures you want to use and how to use them, specifically maps, this will go a long way to helping things, right? The big thing about maps is that you can categorize with them, right? The key being the category, and the value is a list of all the things that fall under the category. That's how you do categorization with maps. So another thing, you'll want to remove it when you're using it to basically play a prank on the people in other classes or roommates or family members or whatever. But you should print out like how many hidden words you have at each guess, like the size of your hidden word list, to see just how it progresses. This will let you know This will let you know that your program's cheating successfully. Okay. Obviously, remove it when you want to play against some unsuspecting rube. The other big thing is like what you do when So the last thing I think I missed, if the player's out of wrong guesses, so suppose they lose, right? How do you show them a word? Well, just randomly select one of the remaining ones from the hidden word list and just show that, and just pretend that was your hidden word all along, and they'll feel really dumb. Okay, so that's the homework for this. And that one's due not this week, but like next Friday, right? Unless I hear stringent objections as to why it should be due next Friday, even though there's an exam there. But I'm not giving you another new assignment, and the content is up. There will be a single question about hash tables. All right. So any questions so far? All right. So